Hello, everybody, and welcome back to another edition or episode, I guess, of Managerial Economics Math Review. So today we're going to be talking about marginal benefit and marginal costs. And so we're given some information here, right? And just to be clear, this is the total benefit that we're talking about right here, right? So this is the total benefit of some amount of goods, right? Some Q amount of goods. And then this red, right, this C right here, this is going to be our total cost. And so we're asked, in the problem, we're asked when are net benefits maximized? So there are two ways to do this. So we'll go through the first way first, and then we'll do the second way. So the first way that we're going to solve it is by using our optimal allocation rule, which is telling us that Q star, that Q that's going to maximize the net benefits, is where the marginal benefit is equal to, and I mean technically it's greater than or equal to, the marginal cost. But, you know, I hear you say, Dr. McCarthy, I don't have the marginal benefit. I don't have the marginal cost. I only have the total benefit and the total cost, right? So we need to do a little bit of transformations here. So let's go ahead and rewrite this equation. And so whenever we're talking about marginal, right, we're talking about the rate at which it increases. And so for those of you that have taken a bit of math, you'll hear that and you'll say, oh, well, that's a derivative, right? So for those of you that don't know any pre-calc or calculus, don't worry about this. There is a shortcut. But for those of you that do, the marginal benefit is nothing more than the derivative with respect to the quantity, okay? So this is our marginal benefit. And so whenever we have some number, so if we have 14x, right? And if we were to take the derivative of that, we would use something called the power rule, right? And the power rule states that essentially we keep whatever constants there. We just go ahead and just copy and paste that. And then we're going to multiply it by whatever that variable is. And then the power rule states that we're going to take 1 away from the variable, and then we're going to multiply the whole thing by 1. And there's actually a better example I'll go through in a second, but I just wanted to go through this since it is the first one that we're doing here, right, where it's q to the 1 power. You can think about that whenever they don't give you a exponent, it's just q to the 1 power. And so what does this end up equaling? Well, 14 times 1 ends up just equaling 14 times x to the, what's 1 minus 1? It's 0. And so an important property to remember here is that anything to the 0 power is going to equal 1. And so this ends up just being 14 times 1. And so the derivative of 14x is just 14. Now that may or may not have confused you or clarified things, so let's go ahead and do another one, but we'll do it with x squared. So again, we'll go ahead and we'll use 14x squared. So to get the derivative, we're going to go ahead and we're going to use the what? The power rule. So the power rule states that I just copy and paste that constant, and then I take this and I'm going to multiply it by that constant, and then I'm going to subtract 1 from whatever that exponent is. So 14 times 2 is 28. X to the 2 minus 1 is just x to the 1 power. And so the derivative of 14x squared is 28x. Okay, so that point being that when we take the derivative with respect to q, we end up with 400 times 1, right? And we don't need to say times 1. We can just have it be 400. And then this, we're going to do that other version of the power rule, right, where we take that 2 and we're going to multiply it by whatever that constant is, and then we're going to subtract 1 from the exponent. And so this ends up giving us 10q to the 1 power. And that's going to be our marginal benefit. So we're going to do the same process for our marginal cost. And let's go ahead and just do it right up here. So our marginal cost is equal to the derivative of this cost function with respect to q. And so it's going to be 3 times 2 times q to the what? 2 minus 1. And so this is going to be 6 times q to the 1, or just 6q. So my marginal cost is equal to 6q. So this optimal allocation rule tells me that I just need to set these two things equal to each other. So I'm going to set this and this equal to each other. So we have 400 minus 10q is equal to 6q. We're going to go ahead and we're going to add 10q to each side. That's going to annihilate the 10q over here. We're going to end up with 400 is equal to 16q, and then this is going to be equal to 25. So our optimal q here will be 25 units. So I told you that there were two ways that we could do this. Well, also I told you that there was a shortcut. So here's the shortcut. If you don't like any of the algebra stuff, or the calculus stuff rather, so here's the shortcut. If the benefit equation, we're going to use some more algebraic terms to represent stuff, right? So the first constant we'll call a times b, or sorry, q, plus b times q squared. So this is how all of your benefit equations are going to show up. And so since this is how all of your benefit equations are going to show up, we can go ahead and have a shortcut for what the marginal benefit is. It's going to be just the constant on that first term. And then it's going to be plus 2 times b times just q to the 1 power. So our marginal benefit is going to be a plus 2bq. And there's a shortcut for the marginal cost as well. So our cost functions are going to be, this one was just a quadratic term, right? 3q squared. So it's going to be something like cq squared. And then our marginal cost is always going to be 2 times c times q to the 1 power. And so it's just going to be 2cq. And so that's our shortcuts if we want to go ahead and do that optimal allocation rule, right? That q star is where the marginal revenue is greater than or equal to the marginal cost. But I said there was another way to do it, and there is, and we'll do it. If you're happy with this way and you understand this way, you don't really need to listen to any more of the video, right? So go ahead and hit the like button and get out of here. But if you're curious, or if maybe that way didn't make the most sense to you, then the second way to do it is to firstly form that that net benefit equation. So net benefits are going to be equal to the benefits minus the costs, right? And essentially, whenever we want to find the maximum of something, right? So to get the maximum of the net benefits, what do we need to do? We need to take the derivative and set it to 0. And so we need to take the derivative of this thing. And so what is the derivative of this is the derivative with respect to Q, right? That's our only variable, so of course it's with respect to that. And so the derivative of the net benefits, right? So would be, so this would be the change, it's not a partial derivative, pardon me, change in the net benefits over quantity, how much, right, is just going to be equal to our marginal benefit minus our marginal cost. And so if we're setting this equal to 0, and then solve for Q star. And so using our shortcuts here, right, we're just going to go ahead and we're going to figure out what A and what B and what C is, right? So in this example, A is 400, B is -5, and C is 3. And so given that, we can skip all the calculus, we can just use our shortcuts, right? And we find that our marginal benefit is equal to 400 minus, right, because -5 times 2, well, let's just do plus 2 times -5Q, and then our marginal cost is equal to 2 times 3 times Q. And so putting all of this together are the change in the net benefits, probably use a different color, is going to be 400 plus, minus, because -5 there, minus 10Q minus, right, because of this, 6Q. And what are we going to do with all this? We're going to set it equal to 0, and we're going to solve for Q star. And so right away you see that this is very similar to the setting marginal benefit equal to the marginal cost situation, right? It's just different ways to do the steps. It's all pretty much the same steps. And so we've got like terms here that we're going to gather together. So we're going to have 400 minus 16Q is equal to 0. We're going to go ahead and put 16Q on both sides. That's going to annihilate this 16Q. We end up with 400 equals 16Q. We divide each side by 16. And we end up with, you guessed it, 25 units as the Q star. All right, well, I hope that that helps everybody in their solving of these net benefit maximization problems. If you do have any more problems, please don't hesitate to reach out and send me an email. Thank you for those of you that have sent an email. It's been really informative. Thanks. All right, hope you have a great rest of your day, everyone.